So, wireless charging at a distance, and when I say at a distance, I mean like 3, 10, 20 meters. I sat down with Sanjay from AirFuel Alliance and our good friend Nick Dutton from Atmosic for a very interesting chat, the first of two this week, on the exciting world of wireless charging at a distance. Enjoy. Let's start, for those who aren't familiar with AirFuel Alliance. Sanjay, what do you do at AirFuel Alliance, and what does it kind of stand for within the field of IoT and technology in general?
So great to be here. AirFuel Alliance is really a standards organization. It's a global organization and a group of companies really who've come together to say, hey, look, there is a lot of potential in wireless power, and we need standards to make it happen, because without interoperability, there's not going to be sufficient deployment, right? We've seen in wireless technology, in anything wireless really, you need standards to kickstart the market. So really we're working on what I call the second generation of wireless power technologies, and for a wide variety of different applications, from consumer electronics to IoT and so on. And looking forward to talking about these topics and get into a lot more detail.
Cool, excellent. And Nick, obviously we've talked to you quite a few times about Atmosic's technology, most recently at CES 2024. But for those of our audience who haven't seen any of the videos, can you give us a brief overview of Atmosic and what they do in terms of the other side of wireless power transfer?
Yeah, well, I mean, Atmosic is really just a semiconductor company. We're focused on standards. So what do I mean by that? I mean Bluetooth, Matter, Thread, Zigbee, things like that. Basically, IoT standards. I guess what makes us a little bit different is that we focus very much from a ground-up design on low power, as opposed to coming from the protocol down to low power. That's quite a differentiator, because what it does is it really does allow us to do what we want without batteries, without corded power. It allows us to use those energy harvesting technologies and effectively run a product without batteries, which is, got a green narrative. It has a convenience narrative. There's a lot of upside to those kind of technologies coming out into the market.
Cool. So I think we've written about it before, but there's an element of energy harvesting via RF with some of Atmosic's products, which I think is how we really connect to this topic with the AirFuel Alliance. So in terms of a discussion, let's start with the discussion of IoT in general and the perception that it isn't green because there's like millions and millions of batteries everywhere. But that's not strictly the case when you consider what AirFuel can offer and wireless power can offer to the equation. So what are kind of what's kind of the limitations of power transfer to start with, and how does this kind of counteract that notion that IoT might not be sustainable?
Well, I will let Sanjay take those points, given he's with the AirFuel Alliance, but I'll throw some stats at you, because certainly the optics of IoT are not good, right? If you look at IoT, it's depending on the report, it's 25 billion by next year, I think it is. 27 billion, I think, is some other numbers I've seen. So, from nothing to something, the optics of that is not good. The other aspect of it is when you look at the waste in battery products, just the batteries alone, they are going to landfills at a rate of 100 batteries per second. Yeah,
I didn't realize it was that bad.
Absolutely. And when you think about that, you're introducing these products, these batteries, these toxins, to an area where they're not native, which may be also close to an area where you're creating food, you're collecting water, and over time these things leach into those areas. So we need to do what we can to reduce that. And so harvesting is obviously a fantastic way of completely eliminating batteries, but also just reducing the number of batteries. If you can extend a product life cycle from a dozen batteries to a single battery, that's a positive effect. Even though it's still ultimately got
Yeah.
a dirty part to it, it's still a positive effect. And so really there's four types of harvesting power supplies, if you like, that we use. The common one is light. Everyone knows about light. You had it on your calculator at school, of course. The next one is motion. Often you see watches, they're powered by motion. Thermal is another. If you get into Europe, in particularly Germany, a lot of the radiators out there, they have thermostats on the side of them, which are
Oh, I didn't realize that. That's nicely done.
Yeah. Electric motors also, they create heat. So in industry, you can get these motors reporting their health without wire pulls. All right. So it's cheap. It works to the convenience
nice.
narrative. And then finally, of course, you've got the RF form of power, which is this wire transfer that we're talking about. And Sanjay is a much better person to talk to this since he lives and breathes it on a daily basis. So I guess I pass over to Sanjay to add some comments.
Yeah, no, so I think thank you, Nick. And great question, right? So I think wireless power is unique in that it does offer the possibility of eliminating batteries completely, right? Not that it's great to reduce the size and the number of batteries, but can you completely replace and build batteryless devices, right? If you can have a small energy source, an RF transmitter sending out energy, and these IoT sensors can be wherever they are placed, they can harvest this energy and use that energy to do their tasks. That's really amazing, right? And now we have the technology where you can do that. And there are two things that have happened actually, to realize how we have reached the current point. The power consumption of our electronics has substantially decreased. And this is due to a lot of the work that Atmosic has done and other similar companies have done, right? Which is an IoT sensor has a sensing element, a small microprocessor to process all of the sensor data, and then a communications element, right? The energy consumed by all three of them has come down dramatically, I would say by substantially over the last few years. And what has happened is the amount of energy that you can send wirelessly and do it safely has actually been steadily growing, and there have been regulatory approvals now that you can send this energy safely, because you absolutely don't want to be sending energy, and the biggest concern is safety when you're doing that. So now those two curves meet. The amount of energy that is there that can be harvested by these devices and their energy consumption, right? So now Atmosic has quite a few sensors today, light, humidity, even an accelerometer that can be completely powered by RF, right? And they can be 3, 5, even 10 meters away from the transmitter, right?
Yeah,
so what that really
that's pretty
means
long
is,
range.
yeah, it's quite impressive. 3 meters looks like, it's very small, but think about 3 meters. Actually, that's if I put it in the center of the room, that's bigger than the office I'm in.
Yeah.
That's bigger than most rooms, right? And that's sufficient. So one transmitter could power all of the IoT sensors in this room, right? Or in a retail environment, or in a hospital, or in a factory, right? And just think about how many batteries you eliminated. And really, I always like to remind myself and others is IoT, like Nick said, massive, massive market growing very fast, but batteries are holding the IoT market back, in my view. If we didn't have batteries, I think people would be deploying a lot more of these. And I think the other aspect, which is actually quite interesting to look at, is when you take the batteries out of these IoT devices, these devices actually become a lot thinner. They're almost like paper stickers that you can make. We all know, right? Unpackaged dies, and small antennas, and they are very thin stickers that you can put that people wouldn't even know they are there. So I really strongly believe that once we have eliminated the batteries from the IoT sensors, the number of IoT devices and the IoT devices market in general is going to grow even more exponentially than we are seeing thus far. So maybe take a breather, and I'm sure you probably have a ton of follow-up questions here too.
Yeah. Well, I think probably the first thing is just out of interest, what kind of power, like how many watts? Obviously, I don't expect it to be watts itself, but how many? What level of power are you seeing in terms of what can be achieved these days wirelessly? Let's say over like a 3 meter distance, for example.
Okay, so we could go into a lot of numbers.
Yeah.
And it's important to know the amount of power that you can transmit, right?
Yeah.
There are approvals now. Number of companies have approvals, let's say at the 915 megahertz ISM band of 1 watt, right?
Okay.
Now, there are equations that tell you if you send out 1 watt, how much of it will be received at different distances and different engineering parameters, beamforming and things like this, right? What is really important is 2 things. One, the regulatory environment is actually fast evolving. As the technology is getting mature and the regulatory bodies are understanding what is safe, because we've never had to deal with this problem before, right? So that is already evolving. So this is why I said there are existing approvals for 1 watt. I expect that number to continue to grow up in the coming years, right? The really important thing is, even when you transmit 1 watt of power, the amount of energy that you can receive, let's say at a 3 meter distance, is sufficient for batteryless operation of a temperature sensor, light sensor, humidity sensor, even accelerometer. MEMS accelerometers are like, Nick, you probably know how much power they take, but these are like in really, really small numbers, right? So it's really less about how much energy is received. The question we should be asking ourselves is, what's the power consumption? What does somebody need, an IoT device need? And I would expect as the power goes up, there'll be an increasing class of IoT devices and sensors that you can now support, right? So what is feasible today, as I said, it's already quite a bit. If you think about light, humidity, temperature, accelerometer, that's a lot of the sensing we do today. And by the way, this includes not just sensing, but processing that data and then sending it over Bluetooth back to the cloud, where it actually becomes useful.
I think that's kind of Atmosic's point, because we're lowering what we need, and they're able to provide more. The developers can actually do more than they used to be able to do. So
Right.
The application scope is growing. It's not that you can only do what you used to do 5 years ago or longer. It's you can do more and more and more. And to come back to the sustainability question, is IoT green? Well, one of the really interesting things for Atmosic, which uses standards, working with alliances like AirFuel, is that the AirFuel protocol is also there. One could argue that this transmitter is constantly pummeling power down to these widgets, but with the protocol that AirFuel provides, I can actually tell AirFuel, I've got enough, thanks, I don't need you anymore.
Oh, okay.
And it'll shut itself down until it. And occasionally we'll check in with each other. But he's green as well. From that standpoint.
Absolutely,
That's a very interesting point. Yeah,
we're just blasting power, right? This power is being sent when somebody needs it, right? So these end devices can request power, right? So that's really, probably maybe not worth going into all the nuances of the standard and why standards are actually essential, right? You want to make sure, because the energy that's coming out of these transmitters, if it's not harvested, it's kind of just goes to waste. Now, 1 watt is not a lot of power. You'll probably spend maybe not even $1 in the entire year, but still, right? You want to be as efficient as possible.
And obviously that'll, as more and more devices and installations happen, then that does build up eventually.
Yeah.
So I guess this brings kind of another interesting question, is because we've got so many things beaming out radio signals as it is, like Wi-Fi, routers, LoRa, gateways and stuff. How does wireless power kind of interact with the infrastructure that's already out there?
Great question, right? So we talked a little bit about safety, right? And I always like to say there are two aspects of safety, right? Safety for living things, humans and pets and so on, but it's also safety for all the other electronics that we have around us, right? And so this is why when we chose the frequencies to use to send out this power, we were very careful about choosing the right frequency so that it will not interfere with all of the existing communications, right? So the reason for choosing the 900 megahertz ISM band that I kind of referenced in passing is because it is an ISM band. That means it is not regulated. There are very few devices out there today. And if you keep your power below certain levels, it will not interfere with anybody, right? So that's really, really important, and choosing the right frequency. So you can rest assured your wireless power transfer, if they conform to the AirFuel standard, will not interfere with your cell phone or your Wi-Fi or Bluetooth, right? And and there are some wireless power systems that operate in those frequencies for, they're kind of showing like proof of concept more than anything else. But yes, you have to be very careful that you are not being, impacting negatively all the other stuff that's happening in wireless today in the spectrum.
Cool. Very good answer. Actually, another question that I'd quite like to ask is, because IoT is a relatively recent field in the way that we see it kind of coming into mainstream conversation, out of interest, when did this really start, this idea of wireless power transfer? And I suppose, when did the battery issue, I guess we could call it, start to be recognized? And was wireless power transfer proposed as a solution to that, or was that developed independently?
It's a great question, right? So if you think about it, and this is kind of my background, right? I come from a cellular background, and I've been on a mission my entire life in terms of eliminating wires, right? And the power cord is the last cord in our lives. That's been kind of what got me into wireless power, and has been a lot of fun. And the holy grail, right? From an experiential perspective, what does everybody want? I don't even want to be bothered by the thought of charging, right? I need my phone, I need my devices, I can just pick them up and they're working, and I don't have to worry about the fact that they have batteries and they need to be charged, right? Clearly, if you want to do it safely, there's going to be a limit to how much energy you can send. And then we're going to talk today at least about the RF, right? There's the long distance wireless power. There's also a near field wireless power technology, which probably we should save for a future date.
Yeah, probably.
Right. That could be a long topic for discussion. So really the RF power, which is, at a distance, right? Substantially more than the wavelengths that we're dealing with. That effort started about, I would say, 4 or 5 years ago, actually, with some of the members of the industry came together and said, look, we need a standard. The technology is maturing. We know it is feasible now, right? And we can do it safely. Now we need a standard to get all the companies together. So we're building products that all can work with each other. You can't, like your phone, right? You go to any country, it doesn't matter who supplied the base stations, they all work. You wouldn't want to deploy IoT infrastructure finding that if a new sensor came along, it needs a different transmitter. That's not going to be a lot of fun, right? That's one easy way to make sure that the market doesn't grow.
Yeah.
Right? So you really need interoperability between the transmitters and the language that these IoT sensors are going to talk. They're still energy constrained devices, by the way. So you don't want to just throw all the overhead onto them and say, go deal with it, right? So you got to really simplify their operation and make it very, very energy efficient at the end. So, like with most new technology, by the way, it does, especially in wireless, it does take a little bit of a time to get everybody to agree and have a spec. But the good news is, after multiple years of effort of multiple companies, we have a standard. And not only that, now we have a certification process, right? It's good to have a standard that companies are going to build to. At the end, we have to make sure that the products will work in the field when they're deployed. So now we have a certification program where when people build products, let's say Atmosic, they can go get their product tested. And then very much like Bluetooth or Wi-Fi, they get to have the AirFuel logo that they can put on their product, which communicates to the larger users and consumers that this product will work, and you can rest assured it will work with, if you buy an AirFuel certified transmitter, this product will continue to work, right?
And I think what's also interesting on this is while Sanjay was talking really about the standard of the power transfer, again, if you remember a moment ago, I spoke about the standard of how I talk back to the transmitter,
Yes.
which is Bluetooth. So in some applications, take electronic shelf labels, which I was thinking about this when Sanjay was mentioning paper thin. If you go to all the shops and so forth, and you see the electronic shelf labels, that shelf label can be powered by the RF transmitter, but it can also be updated by the RF transmitter because the Bluetooth channel can carry the data. So your infrastructure is very standard spaced. It's not just the power transfer part of it, it's the data transfer and so forth.
No,
Cool.
absolutely. Excellent point. It's a full system solution at the end, right? That's ready for deployment.
Yeah.
So in terms of, I think we've had a pretty good conversation on like the background on this topic. So, I mean, technically we could probably go on for hours about this. So I think I'll kind of wrap this up, but with a question about kind of the future of wireless power transfer. So where do you see this in, like, say, 5 years? Will this ever get to the point where there's wireless charging of cars? What's your thoughts on the subject?
Nick, you want to go first?
Oh, yeah. You are touching on a topic that could keep us talking for hours. Well, actually, this happens today. It might not be that it's fully consumer aware. But if you think about, we spent most of this conversation talking about this long range stuff, electronic shelf labels, sensors here, sensors there. But the very short range stuff, if you think about it, a lot of people have been charging their phone for years using wireless power. But yes, the EV car space as well. There's another aspect to the AirFuel Alliance which is very focused on this, where the transmitter's in the ground and you kind of drive over it. But the broad scope, which is really your main question, is where will it go? The answer to that is it's pretty open ended right now. We can go very short range, we can go very long range, we can go do very small power, we can do very high power. Atmosic's positions kind of plonk in the middle of those kind of things. We don't care so much about the phone charging. We definitely don't care about the EV charging. We're in this sensor space.
Yeah.
But the technology as a whole is it's more flexible than people are aware of right now, and it's companies like ourselves, the developers that use our technology, your audience. It's really up to us folks and those folks really to embrace what alliances like the AirFuel Alliance, the Bluetooth SIG and so forth are really trying to do with these technologies. And the reality of it is that it's not that hard to get started. the problem I think most of us are up against is that we're on a timescale that says we need to get this out by, June, July, pick a date. Let's not do anything that we don't already know how to do. And there's a slight hesitance to get started because there's a perception of something different. And the reality of it is it's really not that different than what you've been doing before. You've been doing RF before, you've been doing power before. They're both already there. Let's just try and harvest. Sanjay, what's your view on that?
Yeah, no. So, okay. So as I was telling you, I have a lot of perspective from the cellular industry. So I'm going to use a little bit of an analogy, right? So when I started in cellular a while back, we were in the analog cellular days. Then I was actually involved with the GSM, which was the 2G. I actually wrote 2.5G and 3G standards with my own pen. And, the world has now moved to 5G and we're talking 6G, right? Mm-hmm. Wireless power is in its very early days. We are literally in the first generation technologies that you see deployed. The second generation technologies like the RF standard that we talked about today, it is coming to market now. And you can see the fourth generation technology is what's on your iPhone. You literally stick it with a magnet and you charge, right? It is technically wireless. Most people would say, experientially, this is not wireless, right? I still have a wire.
Yeah, it's still contact.
Still contact, right? It's really, if I ask people, this is Sanjay, this is not wireless. Forget all your physics and whatever mumbo jumbo, but this is not wireless for me, right? So, we now have the ability, like Nick was saying, where we can solve a lot of the experiential things that customers are asking for, what experiences they want, right? So I think the future is exceedingly bright for wireless power. We just need to be just a little bit patient and realize we are in the early days of wireless power, right? And the technology is going to continue to improve dramatically. And absolutely, I expect, our kids would be wondering, what were these wires for? Why did we have any cables, right? I tell everybody, at least I remind myself at the end, wireless power is competing with the outlet on the wall that you have, right? Why does anybody need the last feet of cables that we have? They don't need to exist, right? That's really what we are trying to eliminate from our life. And that's certainly why I got into wireless power. And I'm actually quite confident that will absolutely happen because the technology is there. We know the consumers want it. Absolutely. Who loves cards at the end? Right? So it will happen. It will absolutely happen. And love to talk to you more about, what's the next in line for phones and cars and everything else. But anyways, probably good to stop now.
Yeah, I think we could definitely have a follow-up at some point. So thank you so much, Sanjay and Nick, for joining us at ipXchange. I hope everyone watching / listening had a blast listening to this. I surely did. And very interesting technology, and looking forward to see where it is even in a year's time.
Thank you.
Great.
Cool.
Thanks, guys.
So, I don't know if you felt the same vibe that I did, but I thought that was an incredible discussion on wireless power transfer, which is a mind-blowing technology, especially when you consider that it can be done safely now, and it can be used to eliminate batteries in the IoT, but at the same time still work with all of the data communications infrastructure that we use. But the funny thing is, this isn't the only video this week about wireless power transfer. On Thursday, we'll be releasing a discussion between Guy and Caesar from Energous. Energous makes the transmitter chips that enable this wireless power transfer, and they also make the gateways, if that's what you call them. Call them power bridges. So look forward to that on Thursday, and this is a great week if you want to save the IoT.